Assalamu alaikum student, welcome to daily physics lecture. Today's lecture is 1, 2, 12. So we are at the 12th lecture, and you know for a couple of days I were discussing about Kirchhoff's law, very weird law, and we were solving different good looking circuits. This is also a good looking circuit, but today I will discuss about an interesting circuit. Every circuit is interesting, but it is more interesting and different from the others. So this is a multiple loop circuit. There are too many loops, actually 3 loops. And unlike others, in other lectures, the circuits had at least one line where no resistance remain present, so resistance-less line. But here, see this thing and try to find out the lines. Each and every line has resistance, so it's weird and it's not like the others. So now how we will get current flow? So as I am here, so you need not to think about it. I will get the current flow, you will solve the SW. Okay, so now let's move through these steps. We were talking about these steps again and again for all problems regarding Kirchhoff's law. And here are the steps. Number 1, naming points. Okay, I understand. Let's name the points. So similarly, name the points. I will start from here. A, B, C, D, E, F. Okay, I named the points. So what are junctions? We know E, A, B, D are not junction. F and C are junction. Y is intersecting points, and these are the A's. The A's. So F and C are junctions. We know the junctions F and C. What are the lines? Junction to junction known as line. So here from F to C, one junction to other junction. So lines are F, E, D, C. Okay, F, E, D, C. This is one line. F to C, this is another line, small line. F, A, B, C. That's the other line. So we are done with these 3 lines. Okay, 3 lines means 3 current flow. You have to get all 3. What are the loops? Okay, loops. How many loops are here? Okay. So we know from point to point that's one loop. I already tell there are 3 loops. So from F, E, D, C, F. Okay, F, E, D, C, F. That is the left loop. F, E, D, C, F. Okay, let's think about the right side loop. B, C, F, A, B. Okay, B, C, F, A, B. That means these loop. Okay. There is one more loop, and that loop is the whole damn loop. And this is A, E, D, B, A. That means the large loop. A, E, D, B, A. So A to A, the large one. So 3 loops. Okay, we are done with naming points. We know the name of the points, we know the lines, we know the junctions, we know the loops. Okay, so let's move into step 2. Assume I. Okay, it's not about my assumption, you can assume differently. So as there are 3 lines, so we will go through 3 assumptions, 3 current flow. Okay, F, E, D, C. This is line number 1. Look, F, E, D, C. So let's assume this is the current flow, this is the current flow, this is the current flow. One line, one current flow, I told you. So I assume it's starting from C, moving through E, and then reaches at F. And the amount of current flow is I1. Okay, I1. So that's the current flow. Current flow through F, E, D, C. I1. At the midline, okay, this is a good looking line. Suppose it's I2. It's from C to F. C to F, I2. I assumed it. From F, A, B, C. Okay, this is another line. Suppose it's like this. It's moving like this, downward, left towards left. So that's, suppose it's I3. Okay, I has in 3 current flow. So step 2 done. So let's move through the step 3. Clockwise or anti-clockwise? You know, I always assume clockwise as positive. You need not to. You can assume anti-clockwise as positive. So clockwise positive. It's all about me. Okay, it's all about me. It's not important. You have to assume it as clockwise. So let's step 3 complete. Step 4, junction law. Okay, use junction law. Okay, junction. We have 2 junction F and C. Okay, F and C. Just take any one. Let's take F. Okay, F junction. Use junction law. What is junction law? I in shaman I out. I in is equals to I out. So at F, how many inward current? You can see that I2 is moving inward towards F, right? So I2 is the inward current. Okay, understand. I1 is the inward current. Okay, understand. And this is I3. This is I3. So this is also I3. So I3 is moving outward. So I3 is the only outward current. So here we found one equation which relates I1, I2 and I3. So write it here. I2 plus I1 is equals to I3. That's equation number 1. We got one equation. So if we can get I2 or I1 or I3, any two, we can get the others. Okay? Okay, we have already got one equation. Let's go for the loop law. So we have to use 2 loops. So now in the previous lecture I told you to use a loop which includes a line which is resistance-less. But now here all lines have resistance. So you don't have that shortcut, okay? So what can you do? As you have 3 loops, you can choose, you have to choose 2 at least for 2 equations. You can choose any of the following. Okay, so among these 3 loops, you can choose any 2. I am choosing the left small loop and right small loop. This is all about me. You can choose the large one if you want. So the left loop, we are exactly into the step 5. So left loop, F, E, D, C, F. This loop. Okay, this is the loop. Use Kirchhoff's law. Okay, Kirchhoff's law is summation of E is equals to summation of IR. Okay, how many cells are here left side? Let's find it out. 1 cell, 2 cell. We have only 2 cells. So let's go through this 10. So that's the positive side. The negative, we know the direction of cell acts toward the positive. So if we go through this clockwise direction, clockwise, it is acting towards this 10 is acting towards the clockwise direction. So this 10 is a positive cell. Okay, what about this 8? That is a positive, that is the negative side. So this direction is towards this. Okay. Let me cover this for a couple of moments. Okay, that's 8. Direction of 8. So let's go through this clockwise direction. The direction of 8 and direction of clock is different. So 8 is not a positive cell, it's a negative cell. What about IR? Okay, okay. There are how many resistors are here? Let's find out. 1, 2, 3. We have 3 resistors. 4, 2 and 6. From F to F we have 3 resistors. So let's go through this 4. We have to multiply I and R both. So through 4 the amount of current is I1. So it's 4I1. Let's say it's positive or negative. You can see this current flow is moving towards this direction, right? Okay. So let's go through the clockwise and anti-clockwise, clockwise positive direction. So this current I1 through 4 is acting clockwise. So it's a positive current. So now what about this I1 through 2? So 2I1 current into resistance. It's acting towards this. So that's the direction I1. So it's acting towards this. So this I1 through 2 is also positive, acting towards the clockwise direction. We have another 6 and the current flow through 6 is I2, 6I2. and it is acting towards upward. So let's go for the clockwise direction. So I2 through 6 is not acting clockwise, it is opposite to clockwise. So this is a negative cell. So now let's simplify. So we already got the equation. It's a 3I1 minus 3I2 is equals to 1. So 3I1 minus 3I2 is equals to 1. So that's equation number 2. We have found equation 2. Okay? Let's go for the other loop, the right loop. So let me cover this. The right loop, F, C, B, A, F. F, A, B, C, F. Okay, use Kirchhoff's law. Okay, summation of E is equals to summation of IR. How many cells are here left side? We have 1 cell, 2 cell, 3 cell. We have 3 cells. Okay. So what about this 4 cell? It's acting towards this direction, right? Positive, negative. Positive is towards this direction. So let's go for the clockwise positive direction. Okay, this is the clockwise. The cell is acting opposite to the clockwise. So this 4 is a negative cell. Okay. Let's go for this 10. It is acting towards this direction. Okay. So let's go for the clockwise default positive. You can see that this 10 is acting towards our default clockwise. So 10 is positive. What about this 8? 8 is acting upward, and now we're dealing with the right loop. So let's go for the default clockwise. 8 is acting along our default clockwise. So 8 is a positive cell. We are done with the cells. Let's current and resistance. So let's go through the loop. 1 resistance, 2 resistance. We have 2. So at first go through this 10. So 10. The amount of current which is moving through 10 is I3. So 10 I3. Is it a positive or negative? Let's see. So that's the direction through 10. Let's go for the clockwise. Okay. So that's the clockwise positive direction, and the current flow through 10 is acting along the clock. So 10 I3 is a positive current. We have another 6, and the current flow through 6 is 6 I2. Look, 6 I2, and direction is toward this. So let's go through the default clockwise direction, and the current flow through 6 I2 is acting along the clockwise. So it's also positive. So let's simplify. So now we have got the equation 5I3 plus 3I2 is equals to 7. Put it here. So that's the equation 3. So now we have got 3 equations. Please use the value of I3 here in case of equation 3. Just substitute I3 from equation 1 to equation 3. So from equation 3, if I substitute the value of I here, then 5 into I2 plus I1 plus 3I2 is equals to 7, which means 8I2 plus 5I1 is equals to 7. And now if we consider equation 2, and this is 3I1 minus 3I2 is equals to 1. So now from these 2 equations you can get I1 and I2, and if you get I1 and I2, put it here at equation 1, you will get I3. So by this way you can get I1, I2 and I3. So this was the end of today's problem. In the next day we will discuss about some other but little interesting problem regarding Kirchhoff's law. And the next class will be the last class regarding Kirchhoff's law. Please, if you don't try to watch this video very carefully, and if you don't understand, you know how to contact with me. So please use these times well. Stay inside of your home, stay safe, do SW. Inshallah we all will be okay. And from today, Allah Hafiz, see you tomorrow.